Welcome to this explainer. All right, let's just jump right into it. Today, we're unpacking a really fascinating research paper that, honestly, wants to completely flip how we interact with our own health data. It introduces something called HiMe, which is an open-source, locally deployable platform. Think of it kind of like your own personal health detective. It takes all that raw, messy data from your smartwatch and turns it into personalized, perfectly private insights using autonomous AI agents. But, before we get completely lost in the tech, let's start with a question I think literally all of us can relate to. Your smartwatch tracks absolutely everything, right? Your steps, your heart rate, your sleep cycles, but is it actually making you healthier? If you're anything like me, you probably glance at those numbers, go, well, that's interesting, and then just go right back to your day. It's kind of frustrating, actually. We have these incredible devices collecting a constant, intimate stream of data, but the tools we're given to understand it, they just completely fail to give us any meaningful, actionable insights. Just think about the stark contrast for a second. On your wrist, you've got this modern smartwatch capturing continuous, highly dynamic signals. We're talking heart rate variability and blood oxygen levels updated every single minute. But then, on your smartphone, all that incredibly rich data just gets trapped in these rigid, isolated dashboards. The conventional analytics we're all used to rely on fixed statistics. They'll toss you a daily average or a generic bar chart, but they totally ignore the actual nuances of your unique physiology and your personal lifestyle. And on top of all that, shipping all this highly sensitive, deeply personal data off to cloud APIs, that introduces some major privacy risks.
So enter the solution proposed in the research we're looking at today, HiMe. That stands for the Health Intelligence Management Engine. Now, HiMe is fundamentally different from that standard health app on your phone. It's a self-hosted, privacy-first AI agent platform. What that means is it actually brings the reasoning power of an advanced large language model directly down to your own hardware. So instead of you constantly having to dig through and query your own data, a personal AI agent just lives right alongside your continuous data stream. It's reading it, analyzing it, and acting on it in real time. And the best part? It does the whole shebang while keeping your data entirely local and private.
Okay, let's take a quick look at our roadmap for this explainer. We're going to cover the wearable data problem, introducing the HiMe solution, how the architecture works, smart triggers saving compute, testing the AI models, and finally, real-world user impact. Let's get to it.
All right, Section 1, the wearable data problem. So the researchers behind this paper point out a massive technical hurdle right off the bat. Long-term, raw health data is just way too huge for standard AI context windows. You see, every AI model has a memory limit. That's its context window. If you tried to just dump months and months of minute-by-minute heart rate data into a standard AI, it would basically have a digital panic attack. It just can't handle it. Plus, even if it could, constantly streaming that much highly personal data up to the cloud, that would be an absolute privacy nightmare, not to mention incredibly expensive. Moving right along to Section 2, introducing the HiMe solution.
The research team built HiMe from the ground up based on 3 core design principles. First up, they treat the database as a first-class component. This is huge because it means the AI agent doesn't just passively read your data. It's actively creating its own tables for its memory, learning your user preferences, and setting baseline metrics, so it can analyze everything together. Second is what they call Pareto optimal efficiency. Now, that's just a fancy academic way of saying they found the absolute perfect sweet spot between high-quality analysis, fast processing speeds, and low computing costs. It makes it totally affordable to run 24/7 on normal consumer hardware. And the third principle is combining real-time data processing with long-term user modeling. It can catch a momentary anomaly, like, say, a sudden spike in your stress levels, while simultaneously tracking your overall wellness trends over the span of months.
Which brings us to Section 3, how the architecture actually works.
The paper outlines a really clear 4-step pipeline for how this data actually flows. Step 1, your wearable, whether that's an Apple Watch, a Garmin, an Oura Ring, whatever, collects your physiological signals in real time. Then, Step 2, the companion app on your phone syncs those batches of data over to your local agent server. And right here, there's a special data adapter that normalizes whatever weird proprietary format your specific wearable uses. Step 3, all of this beautifully formatted data lands in a unified, per-user database. This is the magic part, where your heart rate data lives right next to the AI's memory of your current health goals. And finally, Step 4, the agent analyzes this unified pool of data and actually takes action. That could be generating a customized morning report for you, or proactively sending you a notification if something looks off.
I want to really highlight the difference in approaches here, because it's a real game changer. Traditional trackers just hand you isolated snapshots. Your step count is sitting in one silo, your sleep in another, all sent off to some cloud API. HiMe, on the other hand, essentially builds a digital twin of you, because all your vastly different data, your sleep data, your workout history, even the agent's memory of how stressed you were last Tuesday, is all pooled in one unified, locally hosted database. The AI actually learns from you over time. It doesn't just see a heart rate of 110 and freak out. It actually knows, oh, 110 is totally normal for them during their usual Tuesday morning commute. Or, conversely, it recognizes when it's a true anomaly that actually needs your attention.
Let's look at Section 4, Smart Triggers Save Compute.
Now, you might be thinking to yourself, okay, if this AI is constantly analyzing my heartbeat 24/7, isn't it going to literally melt my computer's processor? Well, to solve that, the researchers implemented something they call smart triggers. If you look at the way the signal spikes in the data trace, you'll see what they did. Instead of paying the massive computational cost of running a heavy, complex AI on every single heartbeat, HiMe lets the agent compile your health intentions into cheap, basic statistical rules, things like just checking for a simple standard deviation spike in your heart rate. These little triggers run continuously in the background for practically zero computing cost. They basically act as a bouncer or a gatekeeper, and they only wake up the expensive, highly intelligent multi-turn AI to do a deep analysis when an actual statistical anomaly is detected. It is an incredibly brilliant way to preserve high detection rates while completely slashing the compute burden.
All right, Section 5, Testing the AI Models.
Let's get into the hard science and look at the benchmark tables from the research paper comparing expensive cloud AI to completely free local AI. The researchers basically replayed real public wearable data through the HiMe system to test this. Check out the top row. Gemini 3.5 Flash. That's a major hosted cloud API, and it gets an analysis score of 0.94. But then right below it, look at Qwen 3.5 9B. This is a local model that you can run on your own machine at home. It hits a super competitive 0.87 in analysis, and it actually beats the Gemini API with a perfect 1.00 in its memory score, using roughly the exact same amount of tokens. What this proves is absolutely crucial. Highly capable, totally privacy-preserving local models are now entirely practical for deep, complex health analysis. You don't need the cloud anymore.
And finally, Section 6, Real-World User Impact.
Now, technical benchmarks and tables are great and all, but how did actual human beings respond to this? Well, the researchers conducted a 2-month field study with 9 non-technical participants who just ran this on their own personal devices. And looking at the results mapped out on this radar chart, the scores are honestly incredibly impressive. They used a standard 5-point scale, and the highest mark was for usability, coming in at a whopping 4.67. But personally, I find the trustworthiness score, which was 4.22, and the proactive experience score at 4.56 to be even more fascinating. These users weren't just tolerating this new software. They actually heavily valued the AI agent's ability to proactively reach out with personalized, relevant health plans, all without ever compromising their data privacy. It completely shifted their whole health management experience from being reactive to wonderfully proactive.
We are truly entering an era where you don't have to surrender your most intimate physiological data to massive tech corporations just to get a useful insight. With self-hosted platforms like HiMe, your data stays entirely yours. Meanwhile, a dedicated AI is quietly learning your unique baseline over months, helping you become a healthier version of yourself. So, I'll leave you with this. What would you want your own private 24/7 health agent to discover about you? Thank you so much for joining me for this explainer of the research. Until next time, keep learning.